In commercial buildings, unlike dwellings, you are permitted to feed other receptacles from the bathroom circuit. This allowance is detailed in NEC section 210.11c3, which specifies that small appliance circuits in non-dwelling units are not mandated to be dedicated to a single receptacle outlet. Regarding dishwasher connections, the NEC section 422.16b stipulates that dishwashers must be connected to an individual branch circuit. Therefore, the practice of using a plug-in so-called to connect a dishwasher is not compliant with the code. When it comes to the 90-degree ampacity table, its usage is permissible as per NEC section 310.15b3 when directing wires due to having 3 or more current-carrying conductors within a raceway. When dealing with conduit fill calculations using the 90-degree ampacity table, it is imperative to use the adjusted ampacity values of the conductors. To illustrate, consider an example with number 12 THHN conductors within a raceway containing 3 or more current-carrying conductors. The adjustment factor is applied to the 90-degree ampacity of the conductor. For number 12 THHN, the 90-degree ampacity is 30 amps. Applying the adjustment factor of 0.7, the adjusted ampacity becomes 30 amps multiplied by 0.7, which equals 21 amps. Therefore, the maximum number of number 12 THHN current-carrying conductors that can be installed in the conduit is limited due to ampacity directing and conduit fill requirements. This is in accordance with NEC section 310.15b3. It's important to note that the exact number of conductors allowed will depend on the specific conduit size and fill requirements outlined in the NEC. For the bathroom circuit, NEC section 210.11c3 is very specific. This section distinguishes between dwelling units and non-dwelling units. In dwelling units, bathroom circuits are typically required to serve only the receptacles in that bathroom. This is intended to prevent overloading the circuit with other appliances or loads. However, in commercial buildings, which are classified as non-dwelling units, the restrictions are different. NEC section 210.11c3 permits small appliance circuits in non-dwelling units to serve more than one receptacle outlet. This means that in a commercial bathroom, the circuit can also supply other receptacles outside of the bathroom, provided the total load on the circuit does not exceed its capacity. The key difference lies in the application of the code based on the type of building. Dwellings have stricter requirements for bathroom circuits to ensure safety and prevent overloading. Commercial buildings have more flexibility, allowing the bathroom circuit to serve additional receptacles as long as the circuit's capacity is not exceeded. It is essential to consult the specific requirements of NEC section 210.11c3 and any local amendments to ensure compliance with the electrical code. For the dishwasher connection, NEC section 422.16b provides clear guidelines on how to connect dishwashers to the electrical system. This section mandates that dishwashers must be connected to an individual branch circuit. This requirement is in place to ensure that the dishwasher receives adequate power and to prevent overloading the circuit. The use of a plug-in so-called to connect a dishwasher is generally not permitted under the NEC. This is because dishwashers are considered to be permanently connected appliances and should be hardwired directly to the electrical system. The individual branch circuit for the dishwasher should be sized appropriately to handle the dishwasher's load. This typically involves using a 15 amp or 20 amp circuit breaker, depending on the dishwasher's power requirements. It is important to consult the dishwasher's manufacturer's specifications to determine the appropriate circuit size. The connection of the dishwasher to the electrical system should be made by a qualified electrician. This ensures that the connection is made safely and in accordance with the NEC. Any questions regarding the dishwasher's electrical requirements should be directed to the manufacturer or a qualified electrician. Regarding the 90-degree ampacity table and conduit fill, NEC section 310.15b3 addresses the ampacity adjustment factors for conductors in raceways or cables. This section is relevant when multiple current-carrying conductors are installed in close proximity, such as within a conduit. The heat generated by these conductors can raise the temperature within the conduit, which can reduce the ampacity of the conductors. To account for this effect, the NEC provides ampacity adjustment factors that must be applied to the conductor's ampacity rating. The 90-degree ampacity table can be used when applying these adjustment factors. The 90-degree ampacity rating is the maximum ampacity that the conductor can carry under ideal conditions. However, when multiple current-carrying conductors are installed in a raceway, the ampacity must be reduced to account for the increased temperature. NEC Section 310.15b3 provides the adjustment factors that must be applied based on the number of current-carrying conductors in the raceway. For example, if there are 4 to 6 current-carrying conductors in the raceway, the ampacity must be reduced to 80% of its original value. If there are 7 to 9 current-carrying conductors, the ampacity must be reduced to 70% of its original value. The adjusted ampacity is then used to determine the maximum number of conductors that can be installed in the conduit. The conduit fill requirements of the NEC must also be considered. The NEC specifies the maximum percentage of the conduit's cross-sectional area that can be occupied by conductors. This is to ensure that there is adequate space for the conductors to dissipate heat and to prevent damage to the conductor insulation. To determine the maximum number of conductors that can be installed in a conduit, the adjusted ampacity and the conduit fill requirements must both be considered. The lower of the two values will determine the maximum number of conductors that can be installed. It is important to consult the NEC in any local amendments to ensure compliance with the electrical code. In the provided example, with number 12 THHN conductors, it's important to consider the 90-degree ampacity rating, the ampacity adjustment factors, and the conduit fill requirements to determine the maximum number of conductors that can be installed in a conduit. The 90-degree ampacity rating of number 12 THHN is 30 amps. If there are 3 or more current-carrying conductors in the conduit, the ampacity must be adjusted as per NEC Section 310.15b3. The ampacity adjustment factor for 3 or more current-carrying conductors is 0.7. Therefore, the adjusted ampacity of the number 12 THHN conductors is 30 amps times 0.7, which equals 21 amps. This means that the number 12 THHN conductors can only carry a maximum of 21 amps when installed in a conduit with 3 or more current-carrying conductors. The conduit fill requirements of the NEC must also be considered. The NEC specifies the maximum percentage of the conduit's cross-sectional area that can be occupied by conductors. This percentage varies depending on the type of conduit and the number of conductors. To determine the maximum number of number 12 THHN conductors that can be installed in a conduit, the adjusted ampacity and the conduit fill requirements must both be considered. In summary, NEC Section 210.11c3 addresses bathroom circuits in commercial buildings. NEC Section 422.16b covers dishwasher connections, and NEC Section 310.15b3 discusses ampacity adjustment factors and conduit fill.